using a discriminant, you definitely did do this in Algebra 2, but just a quick reminder of how this works. So if you remember, which you probably don't, but let me remind you, that the discriminant is, let me move myself here. The discriminant is the part of, this is the part of the quadratic formula that's underneath the radical, b squared minus 4ac. Just that, not the radical. We're going to plug into this, and this tells us the type and number of solutions that our quadratic is going to generate. So it can be kind of helpful, especially if you're trying to work a problem and let's say you're trying to factor it and it won't factor. You can just quick plug it into the discriminant and you'll discover if it's supposed to be factorable or not. That's kind of helpful when, like for this year, we're not using a calculator, so we don't get the calculator to help us factor. So sometimes it helps to know, hey, am I wasting my time? So let's see, type and number of solutions. So this little chart just kind of helps you determine what you're dealing with. So if you plug your A, B, and C into the discriminant and it comes up to be 0, then that means that, in fact, you have real, rational roots. And in this case, there's only one. If you remember, if the parabola touches the axis and turns back around, it's got one root right there. That's called a double root. So now the fundamental theorem of algebra tells me that this means I have two solutions. And technically you do, but it's the same solution twice. So if your discriminant comes out to be 0, you're dealing with a double root. So we'll say it's one double root. That helps you to remember that you have found them both and you're not looking for another one. All right, if I plug into my discriminant and I get a perfect square, then again, I have real rational roots, but I have two real rational roots. So I'd be dealing with a parabola that's like this, crosses twice. Let's say I get a positive number, but it's not a perfect square. Well, in that case, the solutions are real, but they're irrational. And there's still two of them. If I work the discriminant and it comes out to be negative, then that means I am dealing with imaginary roots, and there are two of them. So that means you're dealing with a parabola that's like this. It doesn't ever cross the axis anywhere. It could be up here somewhere. Doesn't ever cross the axis, but there are two solutions. They just happen to be imaginary. So let's try a couple. So let's say I have 5x squared plus 2x minus 4 equals 0. So my A is 5, my B is 2, my C is negative 4. Plugging into the discriminant, so just into b squared minus 4ac, that would be 2 squared minus 4 times 5 times negative 4. And just simplify, so 2 squared is 4, minus minus becomes plus, 4 times 5 is 20 times 4 is 80, so I get 84. All right, so it's positive, so I'm not dealing with imaginary roots. Is 84 a perfect square? No. So that means I've got two irrational real roots. Which means if it's irrational, that means the result's going to have radicals in it, like the answers are going to have this in there. It also means it's not going to factor. So that's when, if I'm trying to factor it, if I plug this in and I see that, then I'm like, okay, well, it won't factor. So move on to the quadratic formula. Now let's try a different one. Let's try this. 2x squared minus x plus 1. Oh, by the way, we're not solving these right now. We're just trying to figure out what kind of solutions I'll have. So this is it. Like once you figure out two rational real roots, that's all you're doing for right now. I mean, normally you will solve them, but not right now. All right, my A is 2, my B is negative 1, and my C is 1. So b squared minus 4ac would be negative 1 squared minus 4 times 2 times 1. Simplify that. 1 minus 8, negative 7. So according to my chart, that would make this 2 imaginary roots. And that is it.